Hi. Okay, so I'm stubborn, I know that. Now, we began this actually with an old exercise bike that was thrown away, and we've tried various arrangements on it to try and come up with something that would be sufficient for what we want. And I think I've got it, okay? Now, we started with this thing on the other exercise bike in the previous video. Then we tried this thing, which to be honest was a little bit disappointing. So I had a bit of a look around to see what kind of things were lying around, and of course I've got a ton of these things. And quite a few people have a ton of these things. They're microwave oven transformers. They're that big lump of metal you think has got to be useful for something. So you tend to take them out of a microwave, stick them to one side, and then try to come up with an idea of what to do with it. And I was looking at that thinking, surely, based on this, we ought to be able to do something with this. And that was the thought of it. So what you do with these things, and I'm sure you know, is you cut down that weld line with an angle grinder or a hacksaw, remove the bottom and take out the coils. Now I've taken out the primary coil, which is the great big thick one. We'll have a close-up in a minute. Left the secondary coil in, and then I've glued a load of magnets around in a north-south orientation on this flywheel. A word about these magnets. These magnets are ceramic magnets. Now I bought about 50 of them for about £10, making them about 20p each. If I wanted to buy the same size neodymium magnet, I think they're about £5 each. It'd be a huge amount of money. So I've spent about half a day and £5 on building this thing from a scrap bike and a scrap microwave. And I think that's just awesome. Now, it does an amazingly good job. And it is, I think, sufficient for what we need. Now, a lot of people talk about efficiency, and I've got no idea why they talk about efficiency. It's like efficiency is something that should rule your life. When you think about it, buying a car, which is possibly the third most expensive thing that you're ever going to buy in your life after your house, sending your kids through college, buying your car, it's huge in terms of its expense. Yet I was reading a report on this. They're about 20% efficient on average. The best you'll ever get is 30% efficient. Then nobody cares about it when it comes to cars because cars are so integral into our lives, we don't even question it. We just go buy one, even though the efficiency is just terrible. And that's what I mean. We're not looking at something that's efficient. We're looking at something that is sufficient to do the job. Okay, that's enough of me banging on a bit. What I've got here is a strip of 24-volt DC LEDs. There's about a metre of them there, and they need 24 volts in order to light up. Okay, watch this. Look at that. Oh, that is just awesome. Okay, notice I've stopped cranking. The flywheel's keeping it turning. The lights are staying on. Once it drops below 24 volts, they're going to turn off. So this thing, under load, will do at least 24 volts. Not sure how many milliamps it draws. So what we're going to do now, obviously, is stick it on the meter. Now, I get a lot of people saying, oh, it's going to be different under load. You can't tell anything like that. I disagree. You can tell it's putting something out. It's all an internal yardstick. If I get 1 volt out of this, I know it's not going to light those lights. I've got to get at least 20, 30 volts out of this for it to be able to do something like those, like those lights. And yes, there's a difference between being something under load and something not being under load. That's very true. But if you're using just a meter to tell you something about what it is that you're doing, in my mind, that's sufficient. I mean, it won't tell me what the thing is going to actually generate under load. No, it won't. But it is going to tell me whether it's rubbish or not. When I got a volt reading off this, I knew not to do anything else with it. Of course not. It's only a volt. It's not going to do anything under load. When I span this up, I got 30 volts out of it. And I thought, ooh, that's interesting. Let's attach it to something. So as an internal measure of what it is that can be done, there's nothing wrong with just sticking a voltmeter and ammeter on it. Trying to prove what it's going to actually do, sure, you need to do all that stuff with your load testing, etc., etc., etc. But I'm not trying to prove anything. I'm not trying to prove its output. I'm just wanting to show that it will output. Okay, I do feel I'm preaching a bit, but, you know, sometimes that's necessary. We stick this on the meter. We can have a look at what its no load output is. Now I have got this through a DC rectifier, which is right there. So if I give that a spin up while it's on the meter, let's see if we can get this to camera at the same time. See, I start that turning quite slowly. Look at that. 18, 19, 21, 22, 26, 28, 30, 32, 34, 35. 40 volts out of that. That's astonishing. I mean, it's the cheapest magnets you can buy, ceramics. They're going around an old microwave oven transformer and they're kicking out 30 volts. Now we know it's got some milliamps because we just saw it do a job. So let's have a look, see what it's going to say on here. It says 29 milliamps. Turn it up. $28, $29, $32. So about 30 milliamps at 30 volts, 300 milliamps, 900 milliwatts. So nearly a watt, which is probably what those are. I don't know. And that's what that thing will output. Okay, let's have a closer look at it. So there's the flywheel covered in its ring of north-south magnets. You can see there's the microwave oven transformer. I've put it on a triangle of plastic so there's a tangent to the wheel. And you can see that I've kept the thin wire or the secondary coil here, and that's attached to that secondary coil. And that's all there is to that. Then I crank that handle. It goes through a rectifier bridge right there, and we get our DC output. So there you go, piece of cake to make this stuff from scrap lying around that will do a useful job. We can easily light this strip just by cranking that handle. I guess if we put more of these around we could get more power out of that. We could attach that to a water wheel, I guess, no problem at all. But isn't that awesome? Anyway, I hope you enjoyed that result and thank you very much for watching.